Okay, so today's video will be about force, balanced and unbalanced forces, and net force. So first of all, let's talk about what force is in general. A force is a push or a pull on an object. That's it. So if you're pushing something or pulling something, you're applying force or exerting force on an object. You can do forces, you can push or pull or lift or push down, but there are also forces of nature. And gravity is a big one of those. So gravity is a force that pulls objects toward the center of a large object, which is usually the Earth. Sometimes it's the sun. So gravity pulls the planets in towards the sun, and that keeps us in rotation. But for this unit, we're only going to talk about gravity on the Earth. Okay? So it's a force that's pulling objects towards the center of the Earth. Friction is another type of force, and it's a force between two things that are touching, and it applies force in the opposite direction that the object is moving. So when you rub your hands back and forth, you create a little bit of heat, and that's because there's friction between your hands. It's resisting motion. It's trying to make it stop moving. Okay? When you're walking, the reason you can walk on a sidewalk but you can't walk on ice is because the sidewalk has a lot more friction. It opposes your motion. Where when you're walking on the ice, there's very little friction, so there's nothing to stop you from just sliding right off of it. Okay? So friction is between two objects that are touching, and it moves in the opposite direction of motion. And we will come back to that in a little bit. Okay. Force can affect objects in many ways. So when forces are applied or exerted, the motion of objects can change or not change, depending on what forces are doing. Okay, so one thing the force can affect is the speed of an object. So force can make objects start moving. So if they're stopped, they can start moving. They can speed up, they can slow down, or they can stop. So forces can change all kinds of things about the speed of an object and how fast it's going. The position of an object. Force can make an object move from one place to another. So if you started out standing over here and you apply force to the ground to make yourself walk, you're going to end up over here. So your position has changed. You moved from one place to another. And also the direction. Force can make an object change direction, turn around, go backwards, etc. So if an object is moving in a certain direction and a force is applied, it can make it stop, it can make it turn, it can make it back up, it can make the direction do all kinds of different things, depending on how the force is applied. So these are three big things that we're going to keep talking about with force. It can change the speed, the position, or the direction. And one thing to keep in mind is that when you're applying a force to an object, it is applying a force back on you. So if you are pushing up against a wall, the wall is pushing back on you. For every force, there is an opposite force coming back at you. If you are pushing down on the ground is pushing back up on you. So it's always this kind of, force is coming from all directions at all times. So keep that in mind. Okay, so how do we know how the force is going to affect our object? We have an object that's moving. How do we know if it's going to change what it's going to do? Okay, well, we look to see if the forces are balanced or unbalanced. And we'll talk about how you decide that. So we know how an object's motion will be affected by finding out if the forces are balanced or unbalanced. Forces are balanced if the net force equals 0. And in a minute we'll talk about how you calculate that. But for now, just know the net force, it's a number. If that number is 0, then the forces are balanced. If the forces are balanced, so the net force equals 0, forces are balanced, the object's motion will not change. Okay? A lot of students like to think that if it's balanced forces, the object sits still. But that's not true. Okay? It's not that there's no motion, there's no change. So if you have an object that's sitting still, like my book, okay, I'm holding the book up with a certain amount of force, and gravity is pulling the book down with a certain amount of force. And right now, those forces are balanced because the book is sitting still, and it remains sitting still. Nothing changes. Okay? So there's no change. Now, if we had a car that was going down the road, say 30, 40 miles per hour, and it's going forward with a certain amount of force, gravity is pulling it down, and friction is pulling it backwards, As long as all those forces, when you add them up, equals 0, the car's motion will not change. It's going to keep going straight ahead at 40 miles per hour. Okay? The speed doesn't change, the position doesn't change, the direction doesn't change. It keeps moving. So forces can be balanced even if an object is moving. It just means the motion will not change. Okay? It's an important difference to understand. Okay? An object can be moving and still have balanced forces as long as its movement isn't changing. An object can be sitting still and have balanced forces as long as it doesn't change its motion. Please understand that. Okay. Next, forces are unbalanced if the net force does not equal 0. So I'm going to show you some calculations in a moment. When you add and subtract, if you get anything other than 0, if it does not equal 0, then the forces are unbalanced. So if the forces are unbalanced, the object's motion will change. So again, I'm holding my book. Right now, gravity's pulling down. I'm holding it up. If I suddenly apply more force, then the forces were now unbalanced because I was pushing up with more force than gravity was pulling it down, and the motion of my book changed. It was sitting still, and it moved up. So its speed and its position changed when I lifted it because those forces were unbalanced. Okay? If you have an object that's moving, so say again our car going 30 miles per hour in this direction. If the forces become unbalanced, say the driver, hits the gas to accelerate. So the car is going 30 miles per hour down the street in this direction. They suddenly hit the gas to go faster. So now those forces are unbalanced and our car's motion is going to change. It's going to speed up. Okay? So that car's motion has changed because the forces are now unbalanced. So balanced forces, where your net force equals 0, means the motion stays the same. Nothing happens. Unbalanced forces, where the net force does not equal 0, means that something's going to change. And we'll get to calculating that in just a minute. Okay. So when you're trying to calculate forces, when you're trying to see how forces are pulling or pushing on objects, it's really helpful to make a diagram, a force diagram, or a drawing. Okay? These do not have to be pretty. You know that I can't draw to save my life. But still, if you make even a basic drawing, it's going to help you understand kind of what's going on. Okay? So here, you draw the objects and which direction the forces are acting. Okay? So for my book, I would draw, gravity pulling down on my book and my hands pushing the book up. Okay? You just draw it. It makes it easier for you to kind of visualize what you're looking at. So here, I have a box on a table. That is a box on a table. That's what it's supposed to be. So gravity is pulling the box down because gravity is always wanting to pull objects towards the center of the earth. So gravity is pulling the box in, but the table, bless its heart, is holding the box up. Okay? So gravity is pulling it down on a force of 30 newtons, and the unit for force is newtons. It's just like meters for distance or joules is for energy. We just label it with newtons or a capital N. So gravity is pulling down with a force of 30 newtons, and the table is holding it up with a force of 30 newtons. So now that you've drawn this picture, it's a little bit easier to understand what direction the forces are moving from. Okay? Here's another example. I think I draw a pretty nice basketball. Thank you. So here's, Kobe Bryant. It looks like Kobe, right? And he is pushing his basketball here with a force of 15 newtons. He's pushing it towards the basketball hoop. But gravity is pulling down on that basketball with a force of 20 newtons. So here you can see what direction Kobe has pushed the ball and what direction the gravity is pulling the ball. Okay? So here's the basketball, and it's being acted upon by at least two forces, the push from Kobe Bryant and the pull from gravity. Okay? So we're going to come back to these examples in just a minute. And I'm actually going to sit this down here because we're going to come back to it. Okay. So now we need to figure out, now that we've drawn our diagram and we see what direction the forces are coming from, we need to calculate our net force. And this will tell us if the forces are balanced or unbalanced, and if our motion is not going to change or if it is going to change. So we can tell if the forces are balanced or unbalanced by calculating the net force. Forces moving in the same direction are added together. So if you have two or more forces that are moving or pushing or pulling in the same direction, you add them up. Forces in different directions are subtracted. So if you have forces that are moving in opposite or different directions, you subtract them from each other. Okay? This is very simple math. It's just adding or subtracting. After you do that, if your answer is 0, then your forces are balanced and nothing changes. The motion of your object stays exactly the same. After you add or subtract, if your answer does not, this means does not equal 0, that means something's going to change. It's going to speed up, it's going to slow down, it's going to move, it's going to stop, it's going to change direction, it's going to change position. Something's going to happen. Okay? So you add or subtract as needed. Same direction you add, different direction you subtract. The answer is 0, nothing changes. If it's anything but 0, if it's 1, if it's a million, anything but 0, something's going to change. Okay? And something to keep in mind, the object will move in the direction that has more force. So we're going to calculate that in just a minute. So let's go ahead and go back to our box and basketball examples, and let's calculate our net force. Okay? So here we have gravity that is pushing down or pulling down on the box, and we have a table that is pushing up on the box. So these are moving in opposite directions, so we are going to subtract these numbers. Okay? So we have the gravity, and we're going to subtract out the force from the table. And so 30 newtons minus 30 newtons equals 0. 0 newtons. And so since we have the answer 0, we know that our forces are balanced, and the motion of this box is not going to change. It's sitting still, and it's just going to keep sitting still. Nothing's going to change. So that's all you do. Since these are moving in opposite directions, you subtract, and you see, is my answer 0 or is my answer not 0? It doesn't even matter what the number is. It's just, is it not 0? That's it. 0, not 0. Okay? So let's look at Kobe here. He is pushing the ball with a force of 15 newtons, and gravity is pulling the ball with a force of 20 newtons. So since these are moving in opposite directions, Kobe's moving it this way, and gravity is pulling it this way, we're going to subtract. So we're going to subtract the bigger number, which is gravity, 20 newtons, and we're going to subtract out the push from Kobe. Okay? So you're moving from 20 newtons minus 15 newtons, so your answer is 5 newtons. And since our answer is not 0, it's anything but 0, we know that these forces are unbalanced. And what do we know about the motion? Something's going to change, right? So since this answer is not 0, our forces are unbalanced, and the motion of the basketball is going to change. Which direction is it going to change? Is it going to keep going this way, or is it going to go down? It's going to go down because gravity has more force. It has 20, but Kobe's push only has 15. So he is unfortunately going to miss his shot. Oops, sorry, Kobe. Okay? So this side has more force, so it's going to win. So the ball is going to start falling down this way, its direction is going to change, and it's going to move in the direction that has more force, which is the force of gravity. Okay? So we have some more examples. You can see how some other forces work as well. Okay? So a really common example with forces is tug of war. Okay? So this is my tug of war picture. We have 3 students over here, and they are each pulling with a force of 5 newtons. And these are maybe like 5th graders. Okay? And then we have 2 6th graders over here, and even though there's only 2 of them, they are each pulling with a force of 8 newtons. So let's see who's going to win our tug of war. Okay? So this problem is going to have 2 parts, because we have some forces that are pulling the same direction, like both of these kids are pulling this way, where all 3 of these kids are pulling that way. So since these are moving in the same direction, we have to add them together. Okay? So we're going to add the force of these 2 students together. So the 6th graders' combined force is 16 newtons. Okay? So these 2 kids combined pull with a force of 16 newtons. Where these kids, we're going to add all theirs together because they're all pulling in the same direction. So there's 3 of them. 5 plus 5 plus 5 is 15. Okay? So there's 3 fifth graders, but they're only pulling with a force of 15 newtons because they each pull a little bit less. So they're pulling in that direction with a force of 15 newtons. So now that we have our totals for each side, we're going to subtract because they're pulling in opposite directions now. Okay? So we're going to subtract the larger number and the smaller number. And we're subtracting those because they're moving in opposite directions. We first added up the force on each side, and now we're subtracting out the forces on the opposite sides. So here 16 minus 15 is 1 newton. So this side wins with a force of 1 newton. And this means that these forces are unbalanced. So something about the rope's motion, this is a rope, something about the rope's motion is going to change. So these guys have a greater force by 1 newton, so the whole group is going to move this way because these guys have more force and they're going to move this way with a force of 1 newton. Okay? So we know that something's going to happen here because this answer is not 0. It's anything but 0. So it's unbalanced and things are going to move. And they're going to move this way. Okay? And so our last example, this is my card. This is how I draw a card. Going down the street and it's moving this way with a force of 100 newtons. Okay? It's a windy day out in Texas and the wind is moving against the car with a force of 60 newtons. And also friction with the road, the friction between the tires and the road is working against the car with a force of 40 newtons. So we need to add and subtract here as well. Okay? So these two forces are moving in the same direction, so we're going to add those together. So we're going to add 60 in plus 40 in. Okay? Because these two are moving this way, they're combining their efforts against the car. Okay? So our total in this direction is 100 newtons. So now we're going to subtract because we have force going this way and force going this way. So remember when they're going opposite ways, you subtract. So we're going to subtract the 100 newtons of the wind and the friction, and we're going to subtract out the 100 newtons from the car. And our answer is 0 newtons. And since it's 0, we know that it's balanced. And what do we know with balance forces? Is the motion of this car going to change? No. No change. Okay? This car is going to keep moving in this direction at the same speed, at the same direction, nothing's changing. Okay? So since this answer is 0, there's no change. The motion of the car just stays the way it is. Okay? So balanced equals 0 equals no change. Nothing changes. Unbalanced is anything other than 0, and that means something's going to change. And you calculate those by subtracting opposite directions and adding the same direction. Okay? So hopefully that helps make that a little bit more clear.